Hello everyone, here we have observational study versus design experiment. On this part we have definitions for these two. In observational study, we observe and measure specific characteristics, but we don't attempt to modify these subjects being studied. In other words, here we have no interference. But on the other hand, here for experiment, we apply some treatment. And then proceed to observe its effect on the subjects. So here actually we're using manipulate variables. So you only need to remember that when we have experiment, that means that we applied some treatment, and when it's observational study, there was no treatment in that part. Okay, here is an example for observational study. A good example of observational study is a poll in which subjects are surveyed. So these were surveyed, but they're not given any treatment. So no treatment is on this part. A poll in which respondents are asked who they would vote for in the presidential election is an observational study. So the subjects are asked for their choices, but they are not given any type of treatment. That's why this example is observational study, because we don't have any type of treatment. And on this part example for design experiment, in the largest public health experiment ever conducted, we have 200,745 children were given in treatment. So here we have treatment consisting of the Salk vaccine, and these children were given a placebo. So see, for all of this we have some kind of treatment. That's why this is an example of an experiment. Now here in research, we wish to determine how varying the amount of an explanatory variable. In other words, we call that what we control. So explanatory variable, or what we control, affects the value of what the conclusion is, or what the response variable is, so what outcome is. Okay, example number 1. Researchers examined whether this radio frequency radiation at 2 common cell phones frequency used by digital cell phones cause brain tumor. So they want to see. So this is our outcome. So cause brain tumors in the rats. The rats in group 1 were exposed to the analog cell phone frequency. The rats in group 2 were exposed to digital frequency. The rats in group 3, so in total we have 3 groups, served as controls and received no radiation. So group 1 was analog cell phone frequency, group 2 is digital, and group 3 no radiation. The exposure was done for 4 hours. So this was done for 4 hours a day, 5 days a week, for 2 years. So this is some kind of treatment. So they apply this treatment. That's why this should be experiment. The rats in all 3 groups were treated the same except for the radio frequency exposure. After 505 days of exposure, the researchers reported the following after analyzing data. We found no statistically significant increases in any tumor type, including brain, liver, lung, or kidney, compared to the control group. Okay, now based on that, I'm answering these 3 questions. Is this an observational study or a design experiment? I explained that for here, that since they had it in some kind of treatment, the exposure was done for 4 hours a day, 5 days a week, for 2 years. This is experiment. So designed. That is because we applied some treatment. Okay, right. Okay, these researchers applied that treatment. When I'm writing we, I mean these researchers. Okay. What is the explanatory variable? What, in other words, what is? Okay, here we have explanatory variable is what we control. What we control is exposure to radio frequency. Okay. Exposure to radio frequency, and this is what we control. And what is the response variable, or in other words, what is outcome? Here said cause brain tumors in rat. So that is outcome. So we can write increase in tumor type. This is what the outcome is. Okay, now in this part we have confounding. Confounding in study occurs when the effects of 2 or more, so 2 or more explanatory variables are not separated. Therefore, any relation that may exist between an explanatory variable and the response variable, so what we control, any relationship between what we control and what the outcome is, may be due to some other variable or variables not accounted for in the study. So what that means that we may have other variables, other explanatory variables that are missing here, and we didn't consider those. But actually they affecting our outcome or our response variable. Next part is lurking variables and explanatory variable. This one is very close to that part, but we have a little difference between these two. While working on examples, we can see what the difference is. So is an explanatory variable that was not considered. So this was not considered in a study, but that affect the value of the response variable in this study. In addition, lurking variables are typically related to any, so these are related to any explanatory variables considered in this study. So those variables that are missing actually are related to what we already have for explanatory variables in our study. So let's work on this example and make it more clear. Okay, example, researchers wanted to determine the long-term benefits of the influenza vaccine on seniors aged 65 years and older. The researchers looked at records for over 36,000 seniors for 10 years. The seniors were divided into two groups. Group 1 were seniors who chose to get flu vaccination shot. So this is group 1. They had flu shot. In group 2 were seniors who chose not to get flu shot. So they didn't have flu shot. This group, second group, after observing the seniors for 10 years, it was determined that seniors who get flu shots are 27% less likely to be hospitalized for pneumonia or influenza, and 48% less likely to die from pneumonia or influenza. Okay, so let's see what we have here. Is this an observational study or design experiment? Just remember that for design experiment, we should have some kind of treatment. There was no treatment on this part. They only have some information, some kind of data. No treatment was done here. Okay. That's why this is observational study. They want to see if what is the difference between having flu shot or not having it, but there was no other, so no treatments were applied here. Okay, so observational study. What is explanatory variable? What is that we can control here? Is receiving a flu shot. So that is explanatory variables. And what is the response variable? What is the outcome? Outcome is hospitalization, or what is that? Okay, it's here. Hospitalized for pneumonia or die from pneumonia. So these two are response or outcome. Okay, from the flu. Okay, here we didn't ask us, but let's work on finding confounding and lurking. Because here we had confounding lurking. So variables, let's work on that part too. Let's find other reasons that they may have to have this response, this outcome. Okay, first, confounding. Okay, for this part, I can have under explanatory variable. For example, they may have better healthcare. Better healthcare. Let's have another one for looking variable. So this one is very close to what we have here, receiving a flu shot, but okay, let me go back here. Lurking variables are typically related to any explanatory variables considered in a study, but they are not considered in this study, but actually they affecting the value of response variable. You may have socioeconomic reasons, so socioeconomic status. Another one, they may not have health insurance, or okay, may have or may not have. That's why they're not getting that flu shot. Okay, yeah. Okay, that's it for this one. So you may have different kind of lurking variables that are actually affecting our response. Okay, what we have here, even after accounting for potential lurking variables, the authors of the study concluded that getting an influenza shot is associated with a lower risk of being hospitalized or dying from influenza. Getting an influenza shot is associated with this outcome. So lower that. Okay, so here is that even after accounting for potential lurking variables, so here we got lurking variables. The authors of the study concluded that getting an influenza shot is associated with a lower risk of being hospitalized or dying from influenza. So this was given that receiving a flu shot was the explanatory variable, and we got other variables here, and we call them lurking variables, and we said that these also may affect our response variable, which is what the outcome is in part C. But they, even after having lurking variables, they concluded that getting an influenza shot is associated. So this is associated with lower risk of being hospitalized or dying from influenza. So if they get flu shot, they will not get hospitalized or die from the flu. Next part of observational study do not allow researchers to claim causation, but only association. exactly what we have here. So this influenza shot is associated. This is associated with what the outcome or response is. So this was response. So it's only associated, but we cannot claim causation. We may have different other reasons that may actually cause that response. The next one, a design experiment allows the researcher to claim causation. See, in this example, we had observational study. We didn't have design experiment. So the support here is not for this example we had on top. A design experiment, if we had design experiment, that allows the researcher to claim causation. Okay, so what that means, if this was experiment, they may say that, okay, getting that full shot can cause this outcome. They claim causation between an explanatory variable and response variable. So this is not for that example. Okay, here correlation doesn't imply causation. So even if there was a relationship between explanatory variable and the response variable, that doesn't mean that those explanatory variable affecting or causing what the outcome is. So those variables may not be a main reason for what the response variable is. So this is what that means. So correlation here is relationship, and that does imply that one causes the other, that the explanatory variable causes the response variable. Okay, let me write that here. So it doesn't imply that one, the main explanatory variable causes the other. This one is response variable. Okay, let's see what we have here. Sleeping with one's shoes sleeping with one's shoes on is strongly correlated with waking up with a headache. Therefore, sleeping with one's shoes on causes headache. So here is correlated. What that means, there is a relationship between having shoes on and having headache. Therefore, sleeping with one's shoes on causes headache. You may have different other reasons for that headache not having these shoes on. So let's see what we have here is people. I want to have some other reasons that actually causing this headache. People who sleep with shoes on may be drunk, which would better explain a headache. Okay. So this was what we did on the sport. Correlation doesn't imply causation. we may have different other reasons for that outcome. Another one, as ice cream sales increase, the rate of drowning deaths increases sharply. So ice cream sales increase, rate of drowning deaths increases. Obviously, this is not reason for that outcome. Therefore, ice cream consumption causes drowning. This is totally wrong. We can have different other reasons for that outcome. Okay, people eat ice cream more when it's warm. And people also swim more when it's warm. So swimming more is likely to be related to drowning deaths, not ice cream consumption. So swimming more is likely to be related to what the outcome was. Drowning deaths. Not ice cream consumption. Okay, next page we have types of observational studies. The first one is cross-sectional studies. These are observational studies that collect information about individuals at a specific point in time. So this is what matters. Specific point in time or over a very short period of time. What we have here is one point in time. Next one, case control studies. These studies are retrospective, meaning that they require individuals to look back in time, or require researchers to look at existing records. So this is related to past. The next one is cohort studies. The cohort study first identifies a group of individuals to participate in this study. So they identify a group of individuals first. The cohort is then observed over a long period of time. So this is a long period of time. Over this time period, characteristics about the individuals are recorded because the data is collected over time. And data is collected over time. Cohort studies are prospective. So this part is in future. So follow. the participants into the future. Example, researchers Delmos and associates wanted to determine if having a television in the bedroom is associated with obesity. The researchers administered a questionnaire to 379 12-year-old. After analyzing the results, researchers determined that the body mass index, here we have body mass index of these people who had a TV in their bedroom was significantly higher than that who didn't have TV in their bedroom. Okay, now let's answer these three. Okay, we have 5. Part A. Why is this an observational study? What type of observational study is this one? Because here we only had a survey. Like, okay, they had, what is that? Questionnaire here. Okay, and there was no kind of treatment. That's why this is observational study. Writing the reason for that. So this was observational study since a questionnaire was used only and no treatment. Or in other words, I can write no attempt was made to manipulate the data. Okay, what type of observational study is this one? This one is cross-sectional study because they're not looking back in the time, or they're not collecting data in future. So that's why this is cross-sectional, since researchers observe a single point in time. Okay, writing that for here. Cross-sectional. Since they observed a single point in time. See, here was the definition for that part. Observational study that collect information about individuals at a specific point in time or over a very short period of time. So it's not based on existing records, or is not over a long period of time. It's over a short period of time. That's why this is cross-sectional study. Part B, what is the response variable in this study? What is the explanatory variable? In other words, what is our outcome and what we control here on this part. So response is, or the outcome is body mass index, and explanatory variable, or what we control, is whether TV was in the room or not. Yeah, so that is explanatory variable. First, writing response. Is body mass index. What's this part here? And what we control was whether a TV was in the bedroom or not. So a TV was in their bedroom. Can you think of any lurking variables that may affect the result of this study? So can we have other reasons or other explanatory variables that actually are affecting this response variable? So not only having TV in their bedroom, we may have other reason for that increasing body mass index. It's better to write this one increasing body mass index instead of just writing body mass index. So increasing. So I'm writing this again. Increasing BMI or body mass index. Okay, any other looking variables that affecting response? So the first one can have what is their eating habits. So eating habits. Another one, amount of exercise per week. So we can have these two forward-looking variables that can actually affect response or outcome. Part D, in the report, researchers stated these results remain significant after adjustment for socioeconomic status. What does this mean? This may be because the researchers attempted to avoid confounding variables by taking into account socioeconomic status. They may have not considered some other variables affecting response variables. That is the reason for those parts. Researchers They attempted to avoid confounding So remember what the definition was for that part. Confounding in a study occurs when the effect of two or more explanatory variables are not separated. Therefore, any relation that may exist between an explanatory variable and the response variable may be due to some other variable or variables not accounted for the study. So they don't want to consider that part. They want to avoid these variables on this part by taking to account socioeconomic status. Okay, part E. Can we conclude that a television in the bedroom causes a higher body mass index? Can we have higher body mass index? Based on what we had here, looking variables, we may have other reasons for that. So the answer for this part should be no. Because this one is observational study. So we have association between having TV in bedroom and this outcome. We don't have causation on this part. Remember on this part I said that if you had design experiment, is that here? Okay, this part. If you had design experiment, then you may say you have causation, but in that example we have observational study and we do have association, we cannot claim causation. So this explanatory variable may not be the reason for that higher body mass index. No. So this is observational study. We can only say there is an association between TV in the bedroom and BMI. Okay, between TV in the bedroom and increasing body mass index or higher body mass index. So higher or BMI. Okay, I finished this part.